So today we're going to start chapter 4. Before we go very far in chapter 4, and this is an older worksheet, yours says chapter 4, something different up there, section 2, but I want to start with this page first because this page goes back to college algebra. And in college algebra, you were asked to graph something like y equals 3, x minus 2 squared minus 3. And you had your reasons for learning all of that. And one of the things I want to point out is that this 3, if I got rid of it on this side and sent it over there, that's my k that always goes with y. And you should possibly remember from 103 the x minus h and the y minus k. And it also comes into play when dealing with circles and so forth. But for graphing these crazy bastards, we send the k over, so it's y equals, which is what we're used to seeing. Again, y minus k always went together. X minus h went together. Okay, but anyhow, so here we go. I want to work on graphing this guy right here. Y equals 2 times the quantity x minus 3 squared plus 1. Something you should have had in college algebra. Now, when we graph these, we work from the inside out. So here's the x. What affects the x? Well, the 3, I would subtract 3 first from it. The squared is what's called my parent function. So that I don't worry about, but I take care of the h first. Then I take care of the a because I'm working from the inside out. And the last thing I would do is take care of the k. So, I think I put on yours, it sounds like a hack. I updated it. So working inside out, I take care of the h, the a, and the k. So in college algebra, you should have done this. The h was 3. Again, my equation was y equals a x minus h squared plus k. So looking inside, the h was 3. That was my horizontal shift. That moves me to the right 3. H was the horizontal shift. A was my amplitude. It made me grow bigger, stretched it or thinned it. And then K moved me up or down. So if you had me for college algebra, you would have been asked to do this in 1, 2, 3, 4 graphs. You would have been asked to say, hey, what is the parent function? Y equals x squared. What's the effect of h? Y equals x minus h squared. The third and fourth graphs would have been y, now it's the a, x minus h squared. And then finally, y equals a, x minus h squared plus k. Okay, so we know the parent function, y equals x squared. 1, negative 1, 2, 4, and 2, 4. This is called graphing by translations. Now my h, I had y equals x minus 3 squared, and h is positive 3, so everything is moved to the right 3. I did a horizontal shift. I moved everything to the right 3. The next one, my amplitude was 2, which means things are going to grow faster. So this thing here at 3 is going to be skinnier because all of my y values got multiplied by 3. So, here was 4, 1. When I multiply it by 3, I should now be at 4, 3. Everything got tripled, made it skinnier. You may have heard things like that. Finally, I have y equals 2, x minus 3 squared, and then my k was a plus 1. So I'm going out to this 3, and I'm going to shift my whole graph up 1. And that's how I made all of my students do it, to make sure they understood it, because when they get in college algebra, in trig, they need to use what they've learned in college algebra to graph trig functions, which we're starting to talk about. We have our trig functions sine, cosine, and so forth, then we want to take a look at graphs of those things. Okay? If you've seen this in college algebra, let me see a thumbs up. Ethan did, good. I can only see so many, so Patrick did not. Patrick, do you understand what we just did today? How I went through all of this?
Oh yeah, it just seems really weird.
Okay. Yeah, so a lot of folks from college algebra say graph it, and folks come down here and they put this on their graphing calculator, and they never show that they actually understand the steps of how to get it. They go, oh, look, I got the answer. And no, that's not proving that you actually understand what's going on there.
Yeah, well, I was in math 116, so they kind of just assumed you knew that.
Oh, wow. Okay.
That's called a parabola, right?
Parabola. That is correct.
Yeah.
That is correct. Okay.
Yeah, in my previous class, they wouldn't have us write it out on 4 different graphs. It would just be like we just had to write it on one.
On the final graph. Yeah. And again, people just take their calculators and they're really not showing that they understand what's going on. And this way at least gives some better understanding. Good. I pulled this chart out. This is one we looked at back in chapter 3. And, some of you are like, oh, no, I have to memorize this and on and on. But this was the unit circle chart. So these are values for the unit circle. And if you had this in front of you and I said, oh, what's the cosine of 60? You would go 60, come out. We know the cosine is the first number in the ordered pair. So the cosine of 60 is 1/2. The sine of 60 is the square root of 3/2. But we talked about not memorizing this chart, but boom, draw the 30, 60, 90 triangle, put in the 1 square root of 3 and 2, and you could easily come up with those as opposed to memorizing it. So today we're going to take a look at, what if I change this up a little bit? And I want to look at not my unit circle, but I want to focus on the values that are coming out of the unit circle, these ordered pairs. And this is going to help me lead into, what does the graph of y equals the sine of theta look like? And what does the graph of y equal the cosine of theta looks like? So I started a chart. I'm here, pow, and I wrote down, okay, I have degrees, which I'm familiar with. And these are all the popular ones: 30, 45, 60, 0, 90, 180, 270, 360. Then I added 30, I added 45, I added 60. I added 30, added 45, added 60. So these degree measures are really the same as what's on this chart. And, this is a good exercise, because as I put this together, I'm going, 30 is the same as pi over 6. 45 is the same as pi over 4. 60 is the same as pi over. So I also included my radian ones. And if you were doing this, if we were in a classroom, I probably would have you go through a little bit of this, but we're actually just pulling it right off this chart. Now I went and, okay, let's start with 0 degrees or 0 radians. And we're actually going to be, we're actually going to end up being more interested in our radians. Okay. This is the one we're really going to look at a little closer. And I took the sine off the chart, and the sine is always the second number. So 0, 1/2, square root of 2/2, square root of 3/2, 0, 1/2. And, I didn't do all the hand laborious work of calculating all these. I could come down here to 210, say, or 7 pi over 6, which is 210. And I could say 180 plus another 30. I could get to there. And I know it's 1 square root of 3, 2, negative and negative. And I could come up with the values. So for 210, if I want the sine, there it is, opposite over hypotenuse. But we already have that, and we went through, here's 210, and the sine is the second number. So it's really confusing, but they're actually all tied together. So if I kept going here and I went 225, where are you, 225? Negative square root of 2 over 2. If I went to 240, it's negative square root of 3 over 2. At 270, it's negative 1. So if I filled out this whole column, and then I said, wait, stop. I'd like to know what the graph of this looks like. And when I do the graph, I'm almost always going to work with radians. And I'm going to treat this as right now for y equals the sine of theta. I want to graph that. That means I want this to be my y values. Okay, I kind of think I know what he's doing. So I'm going to look at x values, and my x values are going to go from 0 to pi to 2 pi. Uh-oh, can't see it. 0 to pi to 2 pi. Now we talked about range. We talked about range. I start, come on, I need my camera up a little higher. I know it's harder for you to see, but I start talking about range values. And if this is my radians, and I had 0 radians, I would go to 0 for my first ordered pair up here. Yeah, I think I can see everything now. I hope you can see it. 0 is 0. And I start looking at the values and I go, uh-oh, at pi over 2, I'm all the way up at 1. Well, here's pi over 2, here's 1, I'm up there. Oh yeah, and when as high as 1, it went as low as negative 1. Now my values start getting smaller, and then at pi, I'm at 0. And then my values are going negative, and at 3 pi over 2, I'm down here at negative 1. And yeah, oh look, I don't have all the values in, but I think I see that this guy looks something like this. That's the graph of y equals the cosine of theta. Starts at 0. Again, we're getting all these values from our unit circle. We're using the radians as our x values, and our y values are the sine of theta coming out of this column. Well, what do you think happens here? Well, what do you think happens here? I went around my unit circle once. I'd be going around my unit circle again and again and again. These guys are just going to repeat. And going back this way. They become cyclical. They become cyclical. After a certain amount of time, they repeat. Well, that certain amount of time is called the period. And in this case, the period for this graph is 2 pi. That's how long it goes until it repeats. Really? Yepers. Yepers. Now, what if I started filling in values for the cosine? And if I looked at that chart, at 0, the cosine is 1. At 0, the cosine is 1. At pi over 2, at pi over 2, the cosine was 0. At pi, my cosine was negative 1. 3 pi over 2 at 0, and then I'm back up to 1. So if I took a look at those values, all of a sudden now I'm going to say, well, what's the cosine graph look like? It's going to look really similar. Here's pi, here's 2 pi. I'm only graphing one period because, as you know, this repeats, but it's going to start up at 1. It's going to go all the way down to negative 1 and end up back up at 1. And I'm looking at something that looks like this. And that's the cosine graph. And that's the cosine graph. So now, just like those days back in, where are you? Back in here, when I had parent functions, I had parent functions x squared, I had parent functions cubed, I had parent functions the absolute value. I had a lot of different parent functions that I could do translations on. I now have 2 trig parent functions. And on these parent functions, I can do translations. I can move them left and right, up and down. I could make them grow faster. I can change that period so it goes ba-boom, 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 you know, like a heartbeat and all kind of crazy stuff going on. So let's see what we have. That was a whole bunch of something, and now I need to talk about it. 4.1. The graph of the sine and the cosine functions. They are period functions. They repeat. And we knew for these two that they repeated their period, which is the time to repeat for the sine and the cosine. The sine was 2 pi and the cosine was 2 pi. So they repeated. What did the graph look like? Here it is. Coming right off the unit circle. The domain, this goes on and on and on, and this goes on and on and on, is all real numbers. The range is -1 to 1. Ciao. What do you got?
So with the function like that, how do you figure out the vertex of each of them? If you say that repeat again and again, do you figure out the vertex of those?
So really, this could be, I could have this as the graph. Here's pi, here's 2 pi. I hope I'm answering your questions. Here's 3 pi, here's 4 pi. Again, it goes up to 1 and down to -1. And the sine starts at 0, ends at 0. It goes up there and up there. So there's one period graph. Now it repeats. So it's going to go back up to 1. It's going to go to here, back to there and to there. So it's going to repeat and do the same thing again. And then if I went 5 pi and 6 pi, it would repeat again. If I went in the negative direction, it would repeat again. Here would be -2 pi. Here's -pi. And, you know, I would have the whole kind of thing. It just keeps repeating, repeating, repeating. We were just looking at one period of it till it starts to repeat. Did that answer your question?
So don't have to find out the show the vertex from each of them with the period where just go up and down like that.
Right, right. You're going to show one period until it starts to repeat. There was
Oh, I
the
get it.
sine. Here is the cosine. We just talked about it. Cosine starts at 1 and goes up. So if I said to you right now, what are the values of the ordered pair on the unit circle at pi? At pi, it's going to be cosine. -1, 0. And then, oh yeah, on the unit circle, pi is halfway around. That's at that point, -1, 0. Okay, a little quick terminology. In college algebra, you should have learned about odd functions and even functions. Odd functions and even functions. An odd function, well, yeah, that was why it's called odd, because we started with y equals x cubed. And we looked at something like this. And I said, ew, f of x is right here. F of -x is right there. And they were opposites of each other. What do you mean? Okay, let's let x equal 2 and x equal -2. So if I say f of x and f of 2 and f of -2, what are their values? Well, 2 cubed is 8. -2 cubed is -8. F of 2 is going to equal the opposite of f of -2. So this was our way of dictating what an odd function is. If I pick a number and I pick its opposite, the values are opposites of each other. An even function like y equals x squared. That's when the y value of a number is going to equal the y value of its opposite. And the cosine is like that. Let's go up to x squared. If I picked 4 and -4, and I said, what is f of 4 and what is f of -4? Well, this is 16 and this is 16. So these two guys are in fact equal. If that's true for all numbers, then it's an even function. Somewhere you should have talked about symmetry. This guy is symmetrical over the y-axis. Symmetry. This guy is symmetrical. Symmetry. Well, it's rotated. It's like I picked it up, went 180 degrees. So we say it's symmetrical over the origin. I picked that bad boy up, turned him 180 degrees. Odd functions and even functions. All right, so now we have our basics. We have our two new parent functions, and we're like all happy. We have two new parent functions, and we're going to take a look at, what's going on here. Well, before we did talk about the amplitude that made it go higher and lower. So what happens if I took the sine of 2x? How would that be affected with the amplitude? Well, let's see if I'm going to break this down briefly, and I'm going to say, okay, I know the sine went up to 1, down to -1. This was 2 pi. And the sine started at 0. It's so pretty, and on and on and on. The amplitude says, after you find values, the sine of something, double it. So that means, well, 0 doubled is 0. 1 doubled is 2. 0 doubled is 0. -1 doubled is -2. So when I multiply every value by 2, like we did before with the amplitude, it gets crazier. It doubles everything and doubles everything. So the amplitude, just like in college algebra, can stretch it. The other problem was 1/2, which means I cut all the values in half, and my graph was going to look something like so. So my notes, y equal 2 times the sine of x, that's that red one. Y equals, I'm cutting all the values in half. The next one, kind of different. This guy says, I'm going to mess with the period. And I have y equals 2x to take a look at. So now I'm going to mess with the period. There's got to be some kind of talk about that needs to go here, because I didn't have this guy before. With my other functions, I didn't have it. I had the amplitude. I affected my x right away, which was my horizontal left and right. I had my vertical, as you can see down here in the bottom, which moves the whole thing up or down. But this guy right here is something new. I'm going to mess with the period, and I have to figure out how that guy works. All right, so I'm going to now jump back to that section, I think it's called 4.2 worksheet, and I want to pull that out. Oh man, it's a bunch of pages. Tried to put it up early enough so you were able to grab it before class started and printed it out if you wanted to handwrite it. So my college algebra function was, and I can pull that right back up, something that looked like this. Y equaled A, there's the H, there's the K. My trig function is going to be almost the exact same thing. There's the A, there's the H, and there's the K. Now that F of is just like the power squared, so you saw that generic form a long time ago. Instead of squared, you may have seen F of here. But I now have this B come into play. And I have to figure out what the B is. Well, the B affects the period. The B affects the period. Now, we used to have hack before. Now we have H back. Because if I look inside of here, if I take an X value, the first thing that affects it's the H, then the B, then the period. So working from the inside out, this is my order. That B jumps in there. Okay. First thing I want to do is start with an example. If I'm given an equation that looks like this, I have to separate it out. I have to factor out that B. So this is not good enough. I have to factor out a B, divide by 2 to bring it out, divide by 2. Now I'm in the proper form. What do I have? H is -1/2. B is 2. We're going to talk about it a little more in a second. A is 2. Oh yeah, we just saw an example of that. It goes up higher and down lower. K is -3. The whole thing gets shifted down. So this is something you need to have memorized. Use it enough times and you will. Okay, how does the B work? Well, the B in this case is 2. And when I find B, it affects my period. And what I need to do is say, okay, so if I have B is 2, my period is now going to be the original period, which for sine is 2 pi, and I'm going to divide it by B. So up here, identify B. Okay, that's the first step. And period equals 2 pi divided by B. So in this problem, what would my period be? Well, my B is 2 pi divided by 2. That means I'd have a period of B. All right, where's my scrap paper? Where'd you go? I had scrap paper somewhere. All right, so I'm going to take a look at that. Y equals the sine of X. I know what that is. I'm now asking about Y equals the sine of 2X. Y equals the sine of X. That's my parent function. Here's pi. Here's 2 pi. There's 1. There's -1. I feel so bad. I'm doing all the talking again. Up to here and down. Boom. I got all that. B equals 2. That implies period equals 2 pi, which is the normal period, divided by 2, which equals pi. That means when I graph this, I'm still going as high as 1. I'm still going as low as -1. But instead of being stretched out 2 pi, I now need to do this within pi. Oh boy. So I got that, which means I'm going to start here, go up to 1 and back down by pi over 2, down to -1 and back up to pi. So this guy sort of takes my graph and shrinks him. He changes the period. That darn B changes my period. What do you think about that? I hope you're saying that's wonderful. All right, I got a couple thumbs up. Thank you. I do appreciate that. Okay, so let's see what we have. We're gonna start doing some simple ones. I want you to take 2 seconds and see if you can follow the steps we just talked about. Identify H, B, A, and K, and then graph it. And I'll show you what I mean. So let's see if we can get H, B, A, and K.
Professor, could you show that slide back up, please?
Can I move this back up?
The slide, the previous paper you had up.
Sure. This thing,
Yes.
that's the one
Thank you.
advantage of having a lot of whiteboards. If I was in a classroom, you know, I could have lots of material left on the whiteboards. I'd love to have a classroom with 3/4 of the walls be whiteboards and have students up at the whiteboard all the time. Like, this would be a great activity. What do you think is going to happen? Start to pick a couple of points. How does this work out? But we're condensed. I have to do a lot of it straight from here. Okay, is that good, Ethan?
Thank you.
Yep. All right, so
Hey,
I'm back. Yeah,
Would you be able to, or I guess after we go over that first one, would you be able to go over that example above it?
up
The-
here.
Yeah.
Yeah, we're building to that. We're gonna
Oh.
build. If you can look at this and do this right now, you might as well log off because you're good for today. But we have to, we're gonna take this in pieces. Nice
Gotcha.
and slow. In fact, I know I need to use pencil at this point. Okay, so I'm taking this and I'm saying, wait a minute, y equals a, the sine of parentheses b, x minus h plus k. This is really similar to what you did in college algebra. Here's the amplitude, here's the horizontal shift, here's the vertical shift. The only thing new is we have a b for period, and instead of squared, we have sine, or instead of cubed, we have cosine. We have something different. All right, so I look at h. What is h? In this case, my h is pi. And if you remember what happens here, shifts right pi, because that's a positive number. My b is 1. Nothing exciting happens there. I'm not changing the period with the b being 1. My a is 1, right out front. What's out front? Just a 1. So it's a number. I want to see 1. And the k, I have a plus 0 on the end. So in order to graph this, these are like all the defaults. I don't need to worry about graphing those. All I need to graph is my parent function, y equals the sine of x, and then my new translation, y equals the sine of x minus pi. Oh yeah, here's 2 pi, here's pi. I'm going to make this 1, and I'm going to make this guy -1, just for readability, since there weren't any numbers on there. Go up, ba-boom, ba-boom, ba-boom. There it is. Now you notice -1 and 1 and all the pi's are on there. Well, I need those on there so I could tell. Some people just give me a whatever that graph is and not put any labels, and I'm like, what the heck is this? All right, so this time I'm doing x minus pi, and I already did the work. I'm shifting it to the right pi. So I'm going, uh-oh, this doesn't go out far enough for me. I need to go out to 3 pi, because I only need to graph 1 period. That's all I want. So now what's at 0 gets shifted over to pi. What was at 2 pi, or at pi, is now at 2 pi, and 2 pi is now at 3 pi. So I have a couple of points. There's my 1. There's my -1.
Professor,
Yep.
do you have like a chart, like for if it's supposed to move right, left, like if it's if the variable is positive or negative?
Okay, so you see how the H is here? The H is going to be the number that tells me if it's positive to the right. So if I had this, y equals the sine of x plus 2, what would my H be? What would my -2? So that means left 2. Here I have y equals x minus pi. Y equals the sine of x minus pi. This time my H equals pi. So I'm going right because it's positive. I'm moving the whole thing to the right pi. So
All right, thank you.
yeah, and then when we get to K, when K is positive, it goes up. When K is negative, it goes down. So what you're kind of asking about is what the introduction to 4.2 would be, and that's this guy. And again, come on, sunshine, here we go. I have the y equals, in this case, the cosine of x minus h. So if I looked here, this guy would be, well, let's see, h equals pi over 2. So he's going to be shifted to the say right. I think he means it's going to be shifted to the right pi over 2. Yes, that's correct. That's correct. This one is a little tricky. Why? It's tricky because I have to pull out the b first, which means I'm going to divide that by 2. I'm going to divide that by 2. So I had to manipulate this a little bit first to get it in that standard form. Now, what is my h? And this guy, h equals x minus negative pi over 2. So this guy's going to get shifted to the left pi over 2. I think that plays right into the question you asked, right?
Yes, thank you.
Yeah, okay. Come down here. Say what you want. One bourbon. Sorry. The K on the end. What's this guy's K right here?
Um,
0, right? That's plus 0. So this isn't getting shifted up or down at all. What about this guy? K equals 1. K is the very last thing I do in HBAK, HBAK. I'm going to take my whole graph and shift everything up 1. Again, here's this formula over and over and over. The more you see it, the more you believe. Y equals a cosine of. I had to pull that b out. In this case, b is 2. I divide this by 2 to get just x. I divide this by 2 and pull that 2 out. Let's keep going. Okay. I'm going to put you in pairs. I want you to see what you can do with number 2 and number 3. I'm going to try one more time. Speaker view. And there, I got it. Okay. So when I get ready, first thing I want to talk about is if I have this y equals a cosine b x minus h plus k. If there is no h, that would be a 0. Okay, so if I look at y equal to cosine of x, H is 0. B, there'll always be a B. It's something times X, because if it wasn't, there would be no X. So its default per se is 1. A out front is a times. These are both times, B and A. Okay, B times, A times. H and K, we're adding or subtracting, so their defaults are 0. So when I get ready and I see y equals a cosine of 2x, I know I need to graph the parent function, and I'm going to have to draw a second function to take care of B, because these other three are like default and I don't need to worry about it. Y equals the cosine of x. Whoop, there it is. I changed my period. I divided by 2 and it equals, don't look, don't look, don't look. You were about to correct me, pi. So it's got to be down and back by pi. The next one, instead of messing with the period, I'm messing with the amplitude. We sort of talked about this already. 0, 1, I need the A, and 0. The other three are defaults. I don't need to worry about trying to graph those. Y equals the sine of x. Y equals 2. My amplitude, instead of going up to 1, went up to 2 and down to -2. How's that look? Is that something like y'all got? Yeah. Yeah. Yeah, I'm getting thumbs up. That's awesome. Okay, the last page is the big mama jama, big pajama mama. And as you can see, I gave you 5 graphs. So we're going to have the parent function, which is y equals the cosine of x. And then we're going to have to do somewhere along the line of the H, the B, the A, and the K. Looks like we have all 5 of them come into play. One of the things with this problem, I don't want anyone to panic, but this is the same as -2 the cosine of 3x. Oh, 3x plus 3. The book will sometimes give you the K here. I like to write it this way. So now I have A cosine of B, x minus h plus K kind of deal. All right, I'm putting you in rooms again. Let's see if you can come up with, let's see what you got. Hopefully what you didn't get, you're going to ask about. And if nobody asks questions, I'm like, yes, everybody got it. Let's just do the test now. All right. Yeah, let's see what we have. Y equals -2 cosine 3x plus b. I look for an h. There's not. So it's 0. Number 0, 1, 1, 0. No 0. Next thing I look for is the b. The b is 3. That means the period is going to be 2 pi divided by 3. I don't have to clean anything up. I just know that's now going to be my period. So that's going to be the first thing I take care of. My A, -2. My K is a 3. Questions on getting H, B, A, and K? Yeah, that's the hard part. Yes.
How did you find your period?
Okay. So the coefficient of X, get off there. Just had a pop up. The coefficient of X right here is my B. Okay. So I'm always going to take that B and divide it by the period. Well, the period for the cosine is 2 pi. And I'm going to divide it by B. So it's going to become 2 pi divided by 3. So I got 2 pi over 3.
Okay, thank you.
Is the period. Sure. A is -2 and +3. So I'm going to need the parent 1, 2, 3. I'm only going to need 4 graphs because there's no H there. If there was an H, I'd need to do it in 5. So I only need to do it in 4. So the first part is, can you get H, B, A, and K? Then we roll. First thing is parent function, cosine of X. The next thing is the period, because I'm coming right down this order. I made it easy for you because I put it in that order. Period is 2/3 pi. So instead of being this whole 2 pi, I need to take it and go and scrunch it together. And that's what I did. I scrunched it together and I finished by 2/3 pi. So here's pi. I kind of guessed a little bit at what 2/3 of the way would be. And remember, this would go on and it would just keep repeating and repeating every 2/3 pi. So that's the B. That's kind of usually the hardest one. Now the A, first time we've seen a negative number. When I have an amplitude with a negative number, I flip it. So what I could have done is flip this on a graph and then multiplied it by 2, but I did it all in one. So what was at 1 is now going to be down at -2. What was at -1, when I multiply it by -2, is up at positive. So this guy gets flipped and stretched by a multiple of 2. Finally, the graph gets shifted up 3. So what was here at -2 should now be at -1. What was here at -2? So I didn't have enough room to go 2, 3, 4, 5, because up here, what was at 2 would be up at 5. And again, this repeats. It goes up and it goes up, and it just keeps going and going and going. Questions? That was a whole lot today put into graphing these equations, these trig function equations. But had you remembered, and hopefully you did, had you remembered that a lot of this is familiar from college algebra and how to do it, the only new thing really was the period. Any other questions?